variable here and a bunch of, what happens if you reverse it and put year over there and put all the, oh boy, that doesn't make any mathematical or statistical sense at all. But if you don't tell the software, I'll show you what happens in Jump. But if you don't tell the software that you want to do MANOVA, it's going to assume you want to do 4 one-way ANOVAs, and it's going to do those for you. But here it says MANOVA, and some details about how you want to do the multiple comparisons. Tukey's least significant difference. I would go to least Tukey's honest significant difference, which is more conservative than my least significant difference approach. So, would I argue with John Tukey about this? No, of course not. So what happens when you feed this into SAS or any other software? It spits out p-values. Unfortunately, it spits out the 4 methods: Wilks, lambda, Pilia's trace, Hotelling's trace, and Roy's greatest root. So which one's right? Well, guess what? They're all small. Life is good. Still, in the paper, I've never written all 4 were small. Wilks lambda is maybe the most popular. I don't know. Google. You can choose whichever one you want. Fortunately, in this case, they're all small. So the conclusion is so the sentence in the paper is using MANOVA, all 4 common methods yielded p-values less than 0.0001. Thus, the skulls are different sizes over time. And I probably wouldn't write that sentence. Instead, I would say using Wilks lambda, the p-value was less than 0.0001. So you get a small p-value. Conclusion in yellow, there are differences across time. So how do you, of course, not of course, but we got a small p-value, something's going on. Therefore, what is going on? If you don't answer that question, the reviewers have a reasonable complaint. Like, well, really? So, which measurement is it? I mean, even if the overall goal is really just to say if they're different from each other, you still have to do the individual ones and see which ones are different. So whatever MB is, it gets a small p-value. Whatever BH is, it gets a 0.049, so that's kind of a borderline p-value, but it's less than 0.05. BL gets a really small p-value, and it doesn't appear that NH, whatever that is significantly different across the years. At this point, I would probably start to look at the residuals and things like that, make sure I don't need to do some transformation or something. And I'll show you what I actually did in a second. Oh, more SAS output. SAS and their stupid letter system. You'll see this though, people do this. I should tell you about, I'll save that discussion. The archaic statistics. If the letters so all the C ones are not significantly different from each other. So these, across these 3 years, this particular variable was not significantly different. And you can learn how to read the C notation or the letter notation if you ever have to. There's the situation with BH. That one's VL, and here's the Tukey situation. This is the variable that had a p-value of 0.2, so none of them are significantly different from each other, and so they all get the same letter in this. I would replace Tukey with least significant difference, and I would get more differences than you get using Tukey's method. Here's the one that I made, because I was like, really, we haven't done this analysis correctly without a plot. It's like, come on, you got to at least plot the data. This is over time. To submit this paper without a plot like this is silly. And here you see because this is a plot of the means over time. So it's really simple, right? Anybody can make the plot. JMP makes the plot as a default because it makes sense. And so the first time I got my hands on this data, the end of these slides was here, and I was going, no, we got to find the data. So I went and got the skulls data. And by the way, the small data sets book is online now. At least the data sets are online, so you can track it down. And you see that MB is clearly increasing over time. BH is sort of drifting downward. BL is clearly decreasing over time. And NH isn't doing much. Well, we have a picture now, and that explains a lot about what's going on. Well, if I hadn't gotten small p-values, then I might want to make time a continuous variable. Now the anthropologists would argue, well, we really don't know how old that skull is. And that's why back in the beginning it said these were approximate dates. So I'm not sure that would be necessarily a good idea. But if my multivariate p-value had been 0.08 and my plot looked like this, I'd be going, really? Let's make time continuous. Once you make time continuous, you're going to get a small p-value. And even in, so, because you're taking advantage of the time ordering of the data. And I can show you what happens in JMP. Where's the skulls data? Probably S. I found it here. Skulls. Okay. I'm pretty sure this data is right out of the small data set book. There's the year variable. Those are the measurements of the skull sizes. And over here we see year as a continuous variable, which is not what we want it to be. Why is it labeled as continuous? Well, they're numbers there. It makes perfect sense. So if I don't want it, I right-click on it and make it nominal, analyze, fit model, following the SAS code, I have 4 responses, and year, I'm wondering if year impacts these. I have to tell SAS jump, that I want to do MANOVA, and that's over here on this personality thing. Click on that and go, oh, I want to do MANOVA. And now it's going to do MANOVA. It should come up with my 4 p-values. It doesn't actually. I'll show you why. But hit run. So what are the pictures that come out? We'll come back up to here and why we need that in a second. This is the overall means. Now, is there a year effect? I wanted to make this really big and see if I can get that to, let's shrink this guy. I'm not sure this is the picture that belongs in my report, in my paper, because here's that light blue one, the red one. Oh, maybe I could use this. They're sort of crossing over here, right? But they're sort of in order of time over here. But it's not anywhere near as informative